When simplifying square roots, we always look for square numbers. If it helps you to write these on your paper, I think that would help a lot. So if we're simplifying 125, we're going to rewrite it as a combination of 25 times 5. Simplifying the square root of 25, it comes out as a 5, and we're left with square root of 5. And that is your final answer. The next one, when we look at 120, we want to rewrite it as a combination of these numbers. I'm going to choose 4 times 30. Then we look at our variables and we say, let's rewrite this as x to the 4th times x times y to the 8th. The square root of x to the 4th comes out as 2. 30 is still under our square root. X to the 4th comes out as x squared. X is still under. And then y to the 8th comes out as y to the 4th. The reason I can pull out these variables is because of this fact right here. We want to rewrite x to the 4th as x squared squared, so that whenever we pull it out, these go away and we are left with whatever was under the square root. When adding two radicals, we treat the radicals like variables. If the radicals are the same, we can combine them. If they are not the same, we cannot combine them. So we have 8 and 32. We want to rewrite these and just simplify them as far as possible. Once they're simplified, we'll know if we can combine them. I've rewritten our numbers under the radicals as combinations of square numbers from our list and other numbers. When we pull numbers out, square root of 4 is 2. We're still left with a 2 under the square root. And when we pull out 16, it becomes 4. Once it comes outside, and we have square root of 2. Notice when we pull out the 4, it's multiplied by the 8. Things outside are multiplied together. Now we have 4 root 2 and 32 root 2. We combine these to make 36 root 2. When multiplying square roots, we multiply the outside numbers and we put them on the outside. So negative 2 times 6. And then we multiply the inside numbers, 3 and 9. And we put it on the inside. And then we simplify. Rewriting 27 as a combination of 9 times 3. We can pull out the 9. Whenever we pull it out, it becomes positive 3. And we're still left with our 3 under the square root. Simplifying, we arrive at our final answer. When asked to FOIL with square roots, we FOIL them the same way we would with normal numbers. We do the first numbers, and then we do these. So it's going to be minus root 10. This portion gives us plus root 10. And then this final portion gives us minus root 4. So I'm simplifying here. We have square root of 25 is 5. This portion right here goes away. And if you notice in the original problem, it should, because these two are conjugates. Remember, conjugates allow the middle terms to fall out, and we're left with the first and the last term squared. Our final answer is 3. Our basic definition tells us that I squared equals negative 1. We're going to use this for a lot of different problems on here because we're going to write these as combinations. So if I have I to the 4th, I would write this as I squared times I squared. We said I squared was negative 1, so now we have negative 1 times negative 1, which gives us a positive 1. If I had I to the 3rd, I would rewrite it as I squared times I. I squared is negative 1, because in problem 18 that's what we decided it was, by the basic definition. And I is I. So simplifying this, our answer is negative I. If I already know what I to the 4th is, I would rewrite I to the 7th as I to the 4th times I to the 3rd, because we've already solved for these two. So now we have I to the 4th was 1, I to the third was negative I. So I to the seventh is negative I. Using our pattern, this should make a lot of sense because after 4, it restarts. So an I to the seventh should be the same as an I to the third. Using that same principle for problem number 22, we can say after every 4 cycles, it cycles over. So if we divide 21 by 4, we get 5 full cycles, and we have 1 left. So that means that I to the 21st is going to be the same as I to the 1st, or just I. This is one of the most important problems in this section. We have a negative 72 under the square root. What we want to do is rewrite this as a combination of negative 1 and 72, and then simplify. The negative 1 comes out as an I, because the square root of negative 1 is equal to I. Inside we have 72. And now we want to simplify 72. Writing as a combination of two things multiplied together, we can say that 36 times 2. When 36 comes out, we take the square root of it, and we have 6i times the root of 2. They give you very specific directions over here saying, do not FOIL 24. The reason you're not foiling it is because you're subtracting it. So what we have to do is we have to take our real parts, or the parts without the I, and do them first. So we have 4 minus 2. 4 minus 2 is 2. And then we have to say, let's take our imaginary pieces, or the ones with i's, and subtract them. So we have 3i minus 2i. And we're left with a positive I. Notice the difference between 25 and 24. 24 had a subtraction sign. 25 is multiplying right here. So we will FOIL these. When we do, we get... Notice these were conjugates of each other. So the middle pieces do fall out. And we're left with 25 minus I squared. I squared is negative 1. So now we have 25 minus negative 1. We go plus plus, and we get 26. On 26, if you have an I in the bottom, you want to rationalize that denominator. That means we want to multiply it by something that will get rid of the I. You have two options here. You can multiply this by 3i or I. I'm just going to do I. Notice when I multiplied the bottom by I multiplied the top by I as well. I over I is equivalent to 1, so we're not changing the value of it, we're just changing the way that it's written. At this point we have 5i over 3i squared. We know that I squared is negative 1, so at this point we could rewrite this as with a negative 1 instead of I squared, and now we have 5i over negative 3 as our final answer. More rationalizing the denominator occurs in 27 to 28. If we have 5 plus 3i, then we're going to multiply by that conjugate. Remember that conjugate means that we're going to take the exact same numbers, but instead of a plus, we're going to have a minus. And we're going to do it to top and bottom. Then we FOIL it out. Double check to make sure that you FOILed it correctly, and then we simplify. So we combine what we can combine on the top, we combine what we can combine on the bottom. At this point, we should have these numbers. Instead of I squareds, we want to replace these with negative 1s. Once we replace them with negative 1s, we simplify it, and then we again combine our like terms. At this point, we would want to look at the top and the bottom and see if there's anything that can factor out that can cancel. In this case, there is not. But if we could have taken something from the top, and we could have taken something from the bottom and reduced them, we definitely would want to do that at that point. Rationalizing the denominator on problem 28 looks like this. We multiply by the conjugate and we do it to the top and bottom, and then we FOIL or distribute. Notice on the bottom I jumped straight to 4 minus 4i squared. I did that because I know that multiplying two conjugates together will allow the middle term to drop out, and then you'll be left with the first and the last terms squared. If you don't know that, FOIL it out and check it. At this point, we want to replace I squared with negative 1, At this point, we factor out a 2 from the top, and we simplify the bottom, 9. If these two numbers could reduce, we definitely would reduce them. In this case, 2 and 9 cannot. We know that we're finished. When we have operations under a radical, we treat them like a parenthesis. We still do our order of operations and simplify. Our order of operations would tell us that we'd have to do this exponent first. So we have 16, and then we have subtracting. So subtracting is going to be the very last operation that we do. And we have 3 things multiplied together. When we multiply these 3 together, we get 8. So we have 16 minus 8. Square root of 8 reduces down, and we have 4 times 2. When the 4 comes out, it becomes 2, leaving a square root of 2 as our final simplified answer. If you continue to have questions, please see me before school or during AC Lab, and I can quickly answer them.